Hello and welcome. In this video, I'll be presenting my research on spray aeration techniques used for trihalomethane removal. Now, what are trihalomethane? Trihalomethane are THMs for short, are byproducts commonly found in tap water after chlorination. And chlorination is a disinfection technique used to clean water so that we can drink it. Even though chlorine is very useful in cleaning our water, this disinfection process unfortunately also creates harmful byproducts. And once again, THMs are part of those harmful byproducts. So more specifically, THMs include chloroform, bromoform, bromodichloromethane, and dibromochloromethane. These THMs have a volatile characteristic, that is, this group of chemicals partition to air from the water. However, some of these chemicals are more volatile than others. There have also been studies that show THMs can cause certain types of cancers, and as you can see here, the EPA has established regulations to limit what is considered a safe amount of THMs in water. So what was the goal of this research? Well, to simply put it, the goal was to discover and test an optimal way to remove trihalomethane from water by using the volatile aspect of trihalomethane. The removal method involved a specifically designed water tank. This water tank had a constant volume of water kept inside, with water flowing in through this inlet pipe and flowing out through this outlet pipe at the same flow rate. The inlet water entered the tank through a spray nozzle that would spray the water into fine drops. The roof of the water tank had ventilation holes and ducts installed. One hole was designated as the inlet for airflow while the other was designated as the outlet. A fan was attached to the inlet to cause air to flow into the tank and out through the outlet. Since the experiment was testing what configurations could get rid of the most THMs as possible, there were sample valves located here at the inlet and here at the outlet water pipes. These sample valves allowed for collection of the water so that tests could be run to compare the removal of THMs. This figure right here can help better visualize how THMs are removed from the water. Basically, as air enters the tank from the atmosphere, it comes into contact with the water that has byproducts in them. The volatile characteristics then cause the byproducts to partition to the air. So, the THMs basically need to come into contact with fresh air before reaching the accumulated water to have the best chance at being removed from the water. Here we have previous work done showing that if the air flowed in at a greater volumetric flow rate, the amount of THMs removed were noticeable. With that in mind, I tested if velocity would play a role in THM removal rather than just volumetric flow rate. As you can see here, the equation for volumetric flow rate Q is the velocity of the air V times the area A. And in this case, the area meant those circular holes on top of the tank. The velocity of the air entering and exiting the tank could be controlled by keeping the volumetric flow rate of air constant, while increasing or decreasing the area of the holes. So, three velocities were tested. As shown in this table, these approximate calculations show that just by changing the diameter of inlet and outlet holes, the velocity of the air changes significantly. By comparing these significant changes of velocity to the percent removal of THM, we can see in this graph here that there appears to be no change in THM removal. There does appear to be a minor decrease in bromoform removal as velocity increases, but this decrease may not be statistically significant. In conclusion, the results from the graph suggest that the velocity has little to no effect on THM removal. In other words, THM removal could potentially be independent of air velocity and may primarily rely on volumetric flow rate. Future work could be done on this topic. For example, if a test was done on varying volumetric flow rates while keeping the velocity constant, results could conclude whether THM removal relies only on volumetric flow rate or both velocity and volumetric flow rate. This concludes my presentation. Thank you for watching.